everybody, today we are going to explain the bacteria-based self-healing in the concrete. My group is conformed by Jonah and Quiñones and me, Andres Mejia. Today we are going to explain the different bacteria in the concrete. We know the concrete is one of the most materials used in the world of the construction by their properties. For example, the strength. Hello, today we are going to explain how bacteria act in the concrete today. Thank you. The concrete is one of the most used materials in the world of construction by their properties. The most principal characteristic of this material is the high resistance, but one of their weakness characteristics is the tensile strength. And these characteristics produce some cracks in the concrete, and these characteristics produce cracks to reduce the resistance and the useful life. However, in the different techniques of the engineering have been created to help us to reduce these cracks. Self-curing of concrete with bacteria. In this case, we have the different techniques to curing concrete that this technique is called self-curing concrete. And this consists to add different bacteria with high levels with calcium. And we add these bacteria when we mix the concrete. Okay. When the cracks are formed, the different bacteria act by precipitating calcium carbonate. That consists to fill the difference in the voids of the cracks and shell it. Okay, we have the self-curing of concrete with bacteria. In this case, we have different techniques. We add different bacteria when we mix the concrete. And these techniques are called self-curing concrete. When the cracks are formed, these bacteria act by precipitation calcium carbonate. This consists in fill all the voids in the concrete to shell it. And for the other hand, we have the bacterial concrete is reduced resistance than the traditional concrete.
A self-healing system must have the ability to detect damage or cracks that allows the realize to the healing agent. Science health-selling techniques have a good approach for the recovery of micro cracks in concrete. By adding bacteria to concrete, they will create a permeable layer over the cracks in the concrete. Concrete is a high-quality alkaline material. The added bacteria have the ability to resist alkaline environments and
Is highly alkaline material. To bacteria have the ability to resist the concrete environments are not affected by the concrete. Well, if we have cracks that less than 0.2 millimeters, it will be can repair by the concrete itself. But if the cracks are bigger than 0.2 millimeters, the concrete can't will be prepared by itself, and this will have an opening to the harmful materials to destroy the concrete. Well, we have the types of bacteria, different kind of types of bacteria in the concrete. The several microorganisms have the ability to precipitate calcium carbonate in the concrete. We have the first of them, Bacillus subtilis. These bacteria have the ability to increase the strength with nanoplates. In the second place, we have the Bacillus aereus, and this bacteria in the rice ash is have analyzed help to increase the durability in the concrete has increased since each bacteria is implemented in the concrete. And for the last one, we have the Bacillus sapphiricus, and this bacteria we found the increase the considerability, increase the durability in the concrete, activating the carbonate, calcium in product.
Okay, now I'm talking about the dilatation kinetic. Okay, basically, let's start by the examining how the addiction of bacteria can affect the setting time of the concrete. Depending on the provided calcium source, bacteria can either accelerate or retard this process, especially while calcium lactate can delay setting, while calcium formate and calcium nitrate and calcium oporosity. Okay, now I'm talking about the compressive strength. Okay, now let's talk at how bacteria can improve the structural strength in the concrete of mortar. This is the image. Okay, it wrote a biotechnological method based on calcium precipitation microbial cells obtain nutrients during the initial curing period. This process results in reduce of porosity in the concrete, and permeability is very over of the cement of mortar. Thereby enhancing its compressive strength. The incorporation of different types of bacteria such as Bacillus magnetium and Aspergillus of Pasterius has been shown to significantly increase concrete strength in various studies. Okay, next talking about the water permeability. Okay, let's consider how the bacteria can influence in the water permeability. This is the image of concrete of mortar. Yes, the deposition of calcium carbonate in concrete can reduce its water absorption and permeability. Studies have shown that a team of bacteria such as Pasterius can decrease the porosity and permeability. The new is over of concrete of mortar, thereby improving its durability. Okay, now talking about the toroidal ion permeability. Okay, this is the image that exemplifies this process of this topic. Okay, another important aspect is how the bacteria can affect the permeability of concrete to the toroidal ions, which one often cause reforming steel corrosion. Yes, this is the corrosion. Concrete resistance to toroid permeation can be hinted, including bacteria. Studies have shown that bacteria such as Bacillus subtilis and Aspergillus posterior can significantly reduce toroid penetration into concrete, thereby increasing its service of life. Okay, now talking about the microstructure. This is a topic very important in the structure, concrete, and resistance and durability. Okay, last year let's explore how the bacteria can influence the microstructure. This is the microstructure. This is calcita, the microstructure of concrete and mortar. Calcita precipitation in mortar and concrete improves its impermeability and strength. Some analyses have revealed the presence of bacteria associated with the calcite crystals, confirming their role in enhancing the concrete microstructure. Okay, I will be talking a little about the practical application. Okay, the use of the bacteria in concrete offer practical benefits across several. Okay, this is an image that you can see that the concrete with the addition of bacteria can improve the auto reparation. Hydration kinetics are influenced, affecting certain time bacteria like the Bacillus magnetium in say calcite deposition correlating with the of the 24% around strength increase. Maximum crack Helens and the analysis confirmed in of improved the durability. Okay, in conclusion, this comprehensive study emphasizes remarkable potential of herring use producing bacterial isolated, such as Bacillus bacteria and spores can improve the durability of the concrete. Throughout a thorough examination of various bacterial strains, it becomes evident that their integration into a concrete formulation yields significant and says in crucial properties like compressive strength, water permeability, and resistance of the choroid ion ingress